WASSCE 1993, May-June, Elective Mathematics, question number 9b. When f of x is equal to px cubed minus 3x squared plus 8x plus 36 is divided by x plus 2, it leaves no remainder. I. Find the value of p. II. Hence, express f of x in the form f of x is equal to, into bracket, x plus 2, bracket begins, ax squared plus bx plus c, bracket closes, where a, b, and c are constants, and find the zeros of f of x. Solution. We are told that f of x, when f of x is divided by x plus 2, it leaves no remainder, meaning that x plus 2 is a factor of f of x. So here we are going to use the factor theorem to calculate for the value of the p. Okay, so for the factor theorem, we consider the factor. There's going to be f into minus 2. Because this is plus 2, it should be f into minus 2. Then it will give us what? 0, according to the factor theorem. So we are going to rewrite this polynomial. Then in place of x, we put minus 2. Then we equate to 0. So we have p into minus 2 cubed minus 3 into minus 2 squared plus 8 into minus 2 plus 36 is equal to 0. Now, this becomes p into minus 8 minus 3 into, this will be 4, positive 4. This times this minus 16 plus 36 being equal to 0. Now, when we multiply this by this, we get minus 8p. This times this minus 12 minus 16 plus 36 is equal to 0. Okay, so from here, what do? We simplify. So it becomes minus 8p. When we simplify this, it gives us plus 8 is equal to 0. So here we have minus 8p is equal to, when this crosses, minus 8. Then we divide both sides by minus 8. So we have p being equal to minus 8 over minus 8. So negative cancels negative. 8 goes into itself, 1 goes into this. So the p we are looking for is equal to 1. So the value of p is equal to 1. For the I part of the question, we calculated for the value of p, which is equal to 1. Now, I part of the question is saying that, hence, express f of x in the form f of x is equal to this, where a, b, and c are constants. Okay, so now that we have calculated for the value of p, let us put it in the polynomial. So this becomes 1. Okay, so now this is the polynomial itself. So this is I. Now, so this means that we are going to divide this polynomial by the factor, which is x plus 2. So it's going to be x plus 2 divided by x cubed minus 3x squared plus 8x plus 36. Now, x goes into this, x squared. X times this will give us x cubed. 2 times this will give us plus 2x squared. So what do? We subtract. So when we subtract this from this, it gives us 0. So this becomes negative 3x squared minus. So this gives us minus 5x squared. So then we bring this plus 8x plus 36. Let me clean this portion. Okay, so again, x goes into this minus 5x. X times this gives us minus 5x squared. This times that gives us minus 10x. We subtract. Now, negative gives us positive. So when we subtract this, it will give us 0. Negative gives us positive. So when we add this, it gives us 18x. Then we bring the plus 36. Now, x goes into this plus 18. X times 18 gives us 18x. 2 times that will give us plus 36. We subtract again. This gives us 0. This gives us what? 0. Okay. Okay, so from here, we have the f of x is equal to the x plus 2, then into, this is the other factor, which is x squared minus 5x plus 18. The question says that we should find the zeros of the f of x. So we say for zeros of f of x, we have f of x is equal to 0. So we are going to equate this to 0. So this gives us x minus x plus 2, x squared minus 5x plus 18 is equal to 0. So what do? We are multiplying these two expressions and we are getting 0. So it gives us either x plus 2 is equal to 0, or we say x squared minus 5x plus the 18 being equal to 0. So we pick them individually and solve for x. So here we have x is equal to this crosses minus 2. This quadratic equation has no root, so it doesn't exist. So we say that since the quadratic equation has no roots, it implies it does not exist. So here we conclude by saying that, therefore, the 0 of f of x is equal to minus, or we say is equal to x is equal to minus 2. Subscribe, like, share, and discuss with your friends. Thank you.